Hi everybody. Today we are going to talk about BDB data pipeline module. This helps you to modernize your data engineering process. BDB data pipeline comes with a low-code drag and drop authoring interface, which allows you to quickly build, deploy the pipelines. It supports real-time and batch processing, integration with diverse data sources, APIs, real-time data producers. It allows you to automate your ML and data operations. It is fully decentralized and decouples. This allows you to transfer the responsibility of build, deploy, and monitoring to different teams, as well as to split the data pipeline into various stages like ingestions, transformations, and each of this stage can be owned by different teams. Let's look at key highlights. As I explained earlier, it is event-driven process orchestration. That means each component in the pipeline can act as a producer and consumer of data. And each component talk to other component via an event interface. It supports drag and drop low-code authoring, ML and data ops integration, intelligent process scaling for supporting the high throughput. It is cloud agnostic and fault tolerant. Now let's look at the demo use case which we are going to take as an example today. We are going to talk about an IIoT use case where we are getting data from sensors. These sensors are connected to different equipments. Sensors generate continuous data on set frequencies. These data could be temperature reading, vibrations, pressures, etc. Each of the sensor, there is a set of thresholds, an upper and lower threshold defined, which allows us to see if the machines are running in an optimal state or not. Whenever there is a threshold breach, the plant engineers need to be alerted on a real-time basis so that they can take corrective measures. So the pipeline which we have built for this IIoT use case is split into 4 different stages. The ingestion stage. This stage we will be receiving data in a Kafka topic. Data pipeline support multiple consumers like MQTT, OPC-UA, RabbitMQ, Event Hub, etc. The second stage is DataOps, where we need to enrich the sensor data with details of the machine, thresholds, etc. We also need to run certain rule engine to identify if thresholds are breached or not. The third phase is the ML ops phase, where we have built and deployed a model to identify anomalies in the sensor data. So for this, we have created a model using the DS Lab module. So I'll be walking through a quick introduction about this module as well, and how can you quickly register and operationalize these models. Last but not the least is the data sync phase, where we write all this process data into a data warehouse or an analytics zone where it can be consumed by other applications. We will also look at a testing module which allows you to test the pipeline. You can build your unit cases and test the pipeline. There is a monitoring tool which allows you to monitor the pipeline, how each components are running, what memory and CPU they are consuming. We also have a failure analysis module. In case there are some data failures, you can analyze and see why the failure has happened. We are going to look at a couple of modules in BDB platform: the data pipeline, DS Labs, and data preparation. So let's get into the data pipeline module. So this is the landing page of data pipeline. So you have a couple of options here: list pipeline, create pipeline, list the components in pipeline, delete bot. We are not going to look any of this in this demo. We are going to concentrate how to build the pipeline, test and deploy it. So you can see the status of the pipeline is active. That means it is running. Once you open the authoring tool, you have a canvas where you can define your pipelines. You have a couple of right hand panels. You can see the logs. You can browse objects, various objects or components which are used in different pipelines, so that you don't have to recreate them. You can drag and drop and use it in any pipeline. We have the event panel. We have global variables. So these are the right hand side panel. On the left side, you have the component panel. We have readers. We have writers. ML component, which can run machine learning modules. We have consumers. We have connectivity with various consumers. Similarly, we have producers. It supports variety of transformation, SQL-based transformation, data prep scripts, stored procedures, rule splitters. We also support scripting, remote shell scripting as well as Python scripting. And then there is a scheduler. Now let's look at this pipeline, right? We are receiving data from sensors, and that comes to the Kafka topic. So we have topic here, which is basically an event. So you can map to an existing event where data is already coming, or you can create a new event from this panel. So this is an existing event to which the third-party application is pushing the data. You also have option to connect to external Kafka, where you can drag and drop this Kafka consumer component and connect. Now, when you click on the component, it opens up a metadata tab where you have the basic information about the topic, the metadata, which shows the partitions, number of records present, and there is a preview. So you can see the sample data. It comes as sensor metadata, which is sensor ID and the type of data, value, and a timestamp. Now from this event, there are two components which is consuming the data. One, we are writing the data to a raw data zone using a MongoDB writer component. So you have the writer component here. You drag and drop this component, configure the metadata, and specify whether you need save or append mode or ignore if it is duplicate. You have an option to configure the memory, CPU, and number of instances. So you can increase the number of instances if the data throughput is high, and it has ability to auto scale as well. The second one, you can see it is a DS lab runner. If you go to the metadata, execution type could be script or a model. Now, if you look at DS lab, we have, this is the DS lab module. You have an option to create a project. We already have a project. Let me activate it. So once the project is activated, a container is deployed based on the configuration which you have provided. So if you look at this, this is the container configuration. We have one CPU as the limit, 500 microcore as a request. Memory allocated is 1 GB. There is no GPU support. You can provide the external libraries. And in 2 hours, if there is no use, it will shut it down itself. So let's go back to the project view. Let me go inside this project. You have notebooks, datasets associated with it based on your user access right. You can add datasets to this project. Whatever dataset is visible to you based on your role-based access, you can add it to the project. You have utility area where you can upload your scripts which you have already built. There is a model tab where you see all the models generated by this project. You have an option to register it as an API, unregister from pipeline, or register to pipeline. So you have some filters here. So Those models which are not registered, you can register. If it is already registered, you have an option to unregister. For the notebook, you have option to push it into version control, pull from version control, share it with your team so that you can collaborate and work with them. So let's look at the first component in pipeline, that is a rule engine, which is a script. So this tool allows you to build model as well as to build custom transformation logics as well. So you can do your experimentations here, build your script using whatever logics you like. You have an option to access data sets which you want to bring data from. You can then do your testing here, right? There is a sample data defined and it is sent to the function. So this function, we will be pushing it to pipeline. So once we have built this, there is an option where I can export it to pipeline. Once I click this, it will show the script area. You can use the code blocks which you need to export. So I have not used these blocks, and click next. It will then ask which libraries you want to use. So only PyMongo we are using, and then click export. Once it is done, this is available in pipeline for your consumption. So let's go back to the pipeline. Look at that tool. So we are using a script runner. The project is anomaly detection and the script name is rule engine. So you can see the script, but you cannot modify anything. So as I explained earlier, each component is a consumer and producer. This component, after running the script, it produces the data back here. Let's have a look at the preview. So you can see that we have enriched with some data, right? Like the plant name, where the plant is located, unit, who is the plant engineer, the alert levels, whether any alert is generated or not based on the threshold breach. So you can see those things. Once this data is enriched, it is consumed by a rule engine, rule splitter. It's a standard out of the box component. It has got two outputs. So you can define the number of outputs. And if it is an alert, it is pushed to event called SP rule out. If there is no alert, it is pushed to another event. So if there is no alert generated, we save it back to the database. If there is an alert generated, the alert is pushed to an Azure event grid. So we provide the configuration out here, endpoint and secret, and the data is pushed to the event grid. From there, a mobile application which the plant engineers users consume this so that they can get real-time notification to take action. Also, we have a second fork of that which actually generates a ticket. In this case, it is generating a Jira ticket. So for this also, we have used the data science workbench. We have created a Jira ticket creation script which calls Jira APIs and generate the tickets. So if you look at the Jira, you can see the issues are created. Look at the issue. It says which sensor, which date, all this information you will get. Now let's come back. So this is the script which creates Jira ticket. And the third one basically is we are writing to a database as well. Now there is another fork which is running from the enriched script, which is for the ML flow, which I was explaining to you. So we have used an out-of-the-box SQL component. So the ML model does not support any alphanumeric or string data. So we have removed that. We have just got the machine ID, which is a numeric key. Timestamp we have converted to a numeric value. correlation ID is the ID generated by the pipeline. And once this data is there, we want to enrich it with the threshold so that the model gets those information. So there is an enrichment. This is an enrichment component which can connect to a database. Based on the ID it is receiving, it can pull the information. So if it does not find any record, it can remove or it can attach blank. So this threshold information is pulling from the sensor master data and enriching this data. Let's look at the output of this. So if you look at the output of this, you can see that the alert things are defined here, and it has removed all the alphanumeric data. Now this data is then again passed to another data preparation script. So this is the other module which I was talking about, which is the data prep module. So now look at how we can build transformations using the data prep module. Okay, this is the data preparation module, and let's look at the data set. Right, so this is a sensor threshold data. There is a sample data set. Now you can click on any column, see the profiles. It profiles the data, patterns, etc. You have the transformation scripts here. It support 100 odd transformation. Now for this use case, we are going to look at the expression editor. So I went to the expression editor. I want to check the thresholds and see whether it is a warning or an alert. It has breached any thresholds. Let's look at that way. So what I'm going to do, I have two conditions. So if my value is less than my min threshold warning, or the value sensor is generating is greater than max threshold warning, I want to put it as 1, otherwise 0. And I'll put this as a new column, warning, submit. So if you look at the data set, a new column is created, new step. Similarly for alert also I'll generate. And then I have an option to export these steps to pipeline. Now back to pipeline, you have the script, data prep script runner. You can see the sensor warnings. It has two expression editors. So once this is passed, it generates a data. Let's have a look whether there is any warning. So there are two warnings, no alerts, and this data is then sent to a machine learning algorithm. Let's look at this. It's a model runner. So earlier you were seeing the script runner, and this is a model runner. Now let's have a look at how do you build these models. So I already have these models created here. Let's create a new notebook and let me walk you through how we can build this. So I'm starting a new notebook. This is the first column. So what I will have is the data sets here. So I'll open this. When I click on this, automatically the code is generated. I can run this. Let's see. Once it completes, we can check the data. For the first run to initiate the kernel and establish the session, it takes few seconds. Okay, it has completed the execution now. Now let's see what is there in this data set. So you can see that it is almost a similar data set which our data preparation script has generated. Now I want to run a regression model, right? So let's come to the algos. There is regression. Let's start with a linear regression. So I just click, it generates a boilerplate code. For this, I have to just provide the dataset name and the result column, whatever I need to pop out, and there is a test. And once I run this, it generates a model. And once a model is generated, you have a code here, block here. To save the model, you provide the model name and the name which you want to register the model. Once it is done, you will get those in the models out here. So let's move it to all, right? You will see the models. You can click and register here. Once this is done, your model is ready for production. So the model will be listed in the metadata of the model runner. Choose the project. You can see all the models you have. So the data pass through the inference of the model, and the output you can see is the predictions column. Now, since I want this data for reporting, I need to do some enrichment of this data. So I am again using an enrichment component to bring the sensor ID, sensor name, and other information. So let's have a look at what the output of this is. So you can see the unit name, sensor ID, machine name, everything has come. Now this data is saved to a database. This data I want my data scientist to use this. So I want to do some anonymization using the data loss protection component. So that is a transformation component here, data loss protection. Let's look at the metadata. So I have different types of rule which I can apply at the columns. I have redirection, masking, hashing, data generalized. So in this case, I'm doing a hashing. So it hashes the data, the machine name I'm masking with hash character, and it's a partial mask on the first 5. And in the events, we also have a DB sync event. So DB sync event will directly help you to write it to a database. So this can be connected to a normal Kafka event topic or to a DB sync event which can write to a database directly. So it is asking the table name. Already this is configured in the settings. Let's go to the settings. I can configure the DB sync to a MongoDB or to any of these databases. I think we missed a couple of modules. So there is a monitoring module. You can see the monitoring module, each component, what memory it has consumed, what is allocated. So we can check whether it is optimally allocated or not, how much data it is producing, the logs. So you can monitor each of the components. The second one is the data metrics. So let's go to the data metrics. It generates how much data this module has produced. You can see the green mark. If there is any error generated, it will show the red marks. So there is a failure analysis module. Let's jump to that. So some of them has produced certain errors. So it is due to some failure in MongoDB. We have got this error. Let's look at the DS lab runner. It has some error because it was expecting 9 features, only 7 has come up. So this is the failure analysis module. There is also a test framework. Let's look at that. So it will list all the components. You can create your test cases. So we have created a couple of test cases here. Click on that. Test case description. You have to provide output schema if you want to validate the schema. Input data can be uploaded. Expected output can be uploaded. And when you run this, it can compare number of columns, the actual data, number of rows, or the schema. So you can see the test output. So some failures are there. If it is a failure, you can drill deep. It is expecting 4 columns, but it found only 3. You can see the expected output and the actual output, right? So this way you can build your entire test suite as well. With this, we will come to the end of this session. Thank you.